What if I told you that falling into a black hole doesn't just mean death, it could mean witnessing the most mysterious truth in the entire universe? A place where time freezes, reality breaks, and the laws of physics simply fall apart. This isn't science fiction, it's real. And once you understand black holes, you may never see the universe the same way again. Black holes didn't begin in a lab or a telescope. They began as a mathematical shockwave. In 1915, Albert Einstein released his greatest theory, general relativity. He redefined gravity, not as a force, but as the bending of spacetime by mass and energy. A year later, during World War I, a German physicist named Karl Schwarzschild, using Einstein's equations, discovered something shocking. A solution that pointed to a region in space where gravity becomes so strong that nothing, not even light, could escape. It was the theoretical birth of the black hole. But back then, no one called it that. Not even Einstein believed they were real. For decades, these strange objects were considered mathematical oddities, cool on paper, but far too extreme for reality. Then, in the 1960s and 70s, everything changed. Physicists like John Wheeler, who actually coined the term black hole, and Stephen Hawking began to explore these dark beasts more seriously. And Hawking, he turned our understanding upside down. He showed that black holes weren't totally black. They emitted radiation. They could evaporate. They weren't just destroyers. They were alive in some strange quantum way. Imagine that, something powerful enough to rip apart a star could also slowly fade into nothing, whispering heat into the universe as it dies. But theories weren't enough. We needed evidence. In 1971, astronomers found a powerful X-ray source in the constellation Cygnus. It was called Cygnus X1. Something was devouring a nearby star, but they couldn't see what. It was invisible, yet powerful. This was our first real clue. Black holes weren't just math anymore. They were out there. They were real. So what is a black hole, really? Imagine a massive star, far larger than our sun. At the end of its life, it explodes in a supernova. The outer layers are thrown into space, but the core collapses inward. If it's massive enough, it doesn't stop. It crushes itself into an infinitely dense point called a singularity. Around this point is the event horizon, the point of no return. Once you pass it, you can't come back. Not even light can escape. Time itself slows down as you fall closer. Gravity becomes so strong it stretches your body into a long strand of atoms, a process scientists actually call spaghettification. Yes, that's a real term. And yes, it's terrifying. But not all black holes are the same. Some are stellar black holes, born from dying stars. Others are supermassive, millions or even billions of times the mass of our sun, lurking at the centers of galaxies. There's one of those giants right at the heart of our own Milky Way. And then there's a strange idea. Primordial black holes. Tiny ones that might have formed right after the Big Bang. If we ever find them, they could help solve one of the biggest mysteries in science. What is dark matter? Now here's the challenge. Black holes don't emit light, so how do we find them? We look at what they do. They warp light, twist stars, and sometimes even collide. In 2015, scientists at LIGO detected something extraordinary. Gravitational waves, tiny ripples in space-time, caused by two black holes smashing together over 1 billion light-years away. Einstein had predicted them over 100 years ago, but it's still blowing minds today. Then, in 2019, something even more incredible happened. The Event Horizon Telescope, a global network of radio telescopes acting as one giant Earth-sized dish. There's a lot of white, but right. It was all black hole. Captured the first actual image of a black hole. Not a simulation, not a guess. The real shadow of a supermassive black hole sitting in the heart of galaxy M87. A glowing ring of orange plasma surrounded a black void. This is what the unseeable seen. For the first time in human history, we saw the silhouette of the very thing that even light couldn't escape. But black holes might be more than just the universe's garbage disposals. Some scientists believe that deep inside them, wormholes might exist. Shortcuts through space-time that could connect distant parts of the universe or maybe even different universes entirely. Others think black holes hold the secret to one of science's biggest dreams, a theory of everything. A unification of general relativity and quantum mechanics, also known as quantum gravity. And then there's the biggest puzzle of all, the black hole information paradox. When something falls into a black hole, is its information truly lost forever? Or does it somehow remain encoded in the fabric of space-time? We don't know, not yet. But what we do know is this. Black holes are not just cosmic death traps. They are clues, gateways. They challenge everything we think and we understand about the universe, from the nature of time and space to the limits of physics and imagination. They are the edge of science. And beyond that edge, we don't yet know what lies west. So if that made your brain bend like warped space-time, rewind and watch it again. And if you're ready to go even deeper into the mysteries of reality,